Good morning, guys. Today we're going to give the first half of 10.2, which is arithmetic sequences. Now, an arithmetic sequence is a very particular sequence in which the difference between each term is a constant. That constant is called the common difference. Now, if we look at example 1, they're giving us this infinite sequence. In order to find the common difference, you pick any term and subtract that term from its succeeding term. So you put the succeeding term first and you subtract the first term. So 12 minus 17 equals negative 5. In this case, D, or common difference, is negative 5. As you can see, when we add that common difference to each term, I end up with my actual infinite sequence. So if they ask you find the common difference, again, all you gotta do is take any term, for example 12, and then subtract that from its succeeding term. So you kind of have to go backwards. You find the first term and subtract that first term from the second term, and so on. You will always get the exact same number if it's an arithmetic sequence. Remember, that number is called the common difference, and it is represented by the lowercase letter d. That's it for example 1. Pretty straightforward and very simple. In order to find the nth term, let's say, for example, we actually had that particular infinite sequence, and they asked me let's find first the third term so we can confirm it here, and then let's find the 10th term. All we have to do is follow this formula. So let's say, for example, the third term of this sequence, again, remember, you change your n for 3. The third term is a1, which is the first term, plus n, again, which is 3, minus 1, times my common difference, which in this case was negative 5. I like to put a parenthesis there just so you remember it's a multiplication. If you take away the parentheses, you might confuse it for a subtraction. So either make sure you put a times, a period, or a parenthesis. I like parentheses. So right now, let's go ahead and do PEM to see what we end up with. 3 minus 1 is 2, times negative 5 is negative 10, plus 17. The third term should give me 7. If I confirm up here, the third term is 7. Now let's find my 10th term. Again, you can subtract. You can add negative 5 10 times, which is correct, but very inefficient, or we use the formula. The 10th term is equal to the first term plus the 10th term minus 1 times the common difference. This gives me 9 times negative 5, negative 45, plus 17 is negative 28. Yes. So the 10th term is negative 28. That is example 1. Finding an nth term and finding the common difference. Pretty straightforward. Now example 2, they're giving us a sequence and then they're asking us, give me the formula for that sequence. They're asking to find both the explicit formula, which, represents this. If I were to write let's write the explicit formula of that one right there. So for the explicit formula, you always state the first term, a1 equals 17. So I'm going to state the first term, and I copy it in here, 17 plus, you leave the n expressed as the letter n, minus 1, and we know that the d here is negative 5. Now, that's the initial part of the explicit formula. Note, there isn't any recursion here, because as we saw yesterday, in order for us to see recursion, we have to see more or less this term, which means the previous term. Why does this mean the previous term? Because if I'm looking at A17, when you plug a 17 in here, minus 1 gives you A16. So this term represents the preceding term, and it refers to recursion. So again, here, there is no recursion, but we are working on the explicit formula. Now, I'm not done yet. What we have to do here is multiply this parentheses times this parentheses and join like terms. Then I will be done. So in this case, when I multiply, I get minus 5n plus 5. I'm going to combine these two terms, and I'm left with 22 minus 5n. And now let's confirm to see if this is actually my explicit formula. an equals 22 minus 5n. Remember that my first term was 17. So if I plug in a 1 here, 22 minus 5 is 17. My second term is 12. When I plug in a 2 here, this becomes negative 10. 22 minus 10 is 12. 3 gives me negative 15. Minus 22 minus 15 is 7, and so on. So you can actually confirm that you got your explicit formula correct by just plugging in particular values and confirming. So that's it for my explicit formula. Pretty straightforward. Now, for the recursion, all you have to do is the following. For recursion, you always have to give the initial value. You have to state it explicitly. Well, don't say explicit so you don't confuse it with the explicit formula. You have to state your initial term, okay? And then you say an equals the previous term, and then you just add the difference, the common difference, which in this case is negative 5. If you multiply positive and negative, it becomes negative. So pretty much the recursive formula is an minus 1 minus 5. And I do know that a1 equals 17. So let's confirm my recursion formula. I know my first term is 17. If I want to look for my second term would be, and again, this is an A, by the way, not a 9. My second term would be a2 minus 1 would be a1 minus 5. I know that my a1 is 17, minus 5 is 12. Correct. Now I'm going to plug that in again. In order for to find my third term, it's 3 minus 1, also known as a2 minus 5. a2 is 12, minus 5, a3 gives me 7. So right there, you found the recursive formula. And again, just to be clear, the recursive formula follows this more or less format. You state your initial point. You also write that any term is equal to that previous term plus the common difference. I say plus the common difference even though this is minus, because again, the difference was negative 5. So when you add a negative, it's the same thing as a subtraction. So again, this would be the recursive formula. If they ask you for the explicit formula, you write the explicit formula. If they ask you for the recursive formula, you write the recursive formula. Pretty straightforward. That's it for example 2. Now for example 3, we kind of already did it, and that's just finding the nth terms of said arithmetic sequence. For example, in the first example, they give me 25, 17, 9, So in order to find, and they're asking me, first find the common difference, and then let's find the 68th term. So find the common difference, and then find the 68th term. Step 1, let's find the common difference. Pick any term and subtract the preceding term from it. So again, the common difference is negative 8. I have my common difference right there. Now, all I have to do is pretty much, give me a second. Again, I'm just using the format they have in the book just to make sure we are all correct. And we're gonna write, there is no recursion here, just in case. This is pretty much just plug the values into the recursive formula. A1 plus n minus 1 times d. I know that my d is negative 8. I know my n1 is 25. So let's go ahead and substitute everything. A 68, because I'm looking for my 68 term, equals 25 plus 68 minus 1 equals 67 times negative 8. Let's multiply. I don't have a calculator at hand. 67 times negative 8. 8 times 7 is 56. Carry 5. 8 times 6 is 48. Plus 5 is 53. Negative. So I have that the 68 term equals 25 minus 536. Combine these two, it gives me 20. That gives me 16 minus 511. Hey, correct. Seems I can still find a job as a math teacher after all this time. So the actual 68th term of this arithmetic sequence would be negative 511. Again, to repeat, this is the original nth value formula, the first term plus n minus 1 times d. Then all you gotta do is plug in the values. I know my first term because they're giving me the first term. They're asking me for the 68th term, minus 1, and you plug in the d, which is the common difference, negative 8. PEMDAS, and you're done. That's all you have to do. And that is today's class. Now, the second one, example B, includes fractions. It's the exact same thing. Just multiply the answer times the fraction and divide. Again, if you have problems, let me know, but you shouldn't at this, at this level, have any problems with these types of exercises. So, for homework, please do the following. Please do number 1, number 2, number 8, 1, 2, and 8. Those are all example 1s. For examples 2, please do 1 and 17. And that's finding the explicit and the recursive formula, both formulas. And for example 3, just do 18 and 19. That's it. You should have those done in 15 to 20 minutes tops. If you have any questions, let me know. Remember, tomorrow, it's going to be a review day, formal review day for the vector exam on Monday. I'm not sure yet if it's going to be a live test or a quizzes test. I'm going to be working on quizzes today to see if I can upload a practice test tomorrow or Friday. If I find that I'm not liking how it shows up in quizzes, I will do a live test. I'm not sure yet, but by Friday you will know. You will know by Friday if it's going to be a live or a quizzes test. If it's going to be a live test, it will be way shorter than the previous one. The previous one took us anywhere from between 20 minutes to 50 minutes, some students. This is going to be maybe 2 or 3 examples. But given the case that there's only going to be 2 or 3, if it's a live test, it will be slightly more difficult. But again, I will be there to guide you. There will be partial credit, etc., etc. So go ahead, turn this homework in before 11. If you have any questions, let me know. Otherwise, have a great day, guys. See you soon.